So I'm recording now, and we are coming back to the rest of chapter 4.2. And we did this problem at the very end of class, but I know I kind of rushed you through it, and I know that we might have been done for the day when I made us think through this problem, so we'll just talk through it again. These are all word problems that have to do with trig. We're either finding a side length or we're finding an angle length. And this exact problem is talking about a squirrel at the top of the tree. I labeled it with an S because I wanted to know where everything was. These pictures don't have to be great, but you need to know exactly what's going on. So the squirrel's at the top of the tree, and the tree is 52 feet, which is why I labeled that right side 52. He's looking at a nut on the ground over here, and his angle of depression is 23 degrees. Now, I know that this might be silly, but I want everyone to put their hands out in front of you. And I want you to do angle of elevation and depression with me. If you look up, that's angle of elevation. So we're looking like upward this way. Everyone see angle upward, elevation. Same thing if you go downward, it's depression. Down is depression. So I even think this in my head when I'm looking at this picture. I'm like, okay, if the squirrel's looking down, even if you just do it with like your little hands, this is my angle down. What a lot of people, I know that this looks silly and maybe inappropriate, but what a lot of people want to do is they want this angle right here, which I don't know if you guys online can see, but they want to do like the top of the tree with the hypotenuse. That's not an angle. This is not a view I can look at. I can look up, I can look down. Those are my only two options. So what I drew is like a pretend line of the squirrel's line of sight, and then I drew down, which is 23. Do you guys remember back in geometry, if you didn't black it out of your memory, when we spent like a whole bunch of weeks talking about parallel lines? We were like, if lines are parallel, then, and one of the things we said a lot was alternate interior angles are congruent. Does that ring any bells? If lines are parallel, alternate interior angles are congruent. These two lines right here, this like dashed gray line is parallel to the ground. The squirrel sees at like a flat angle, the ground is flat. Those are parallel lines. And so if I know the angle of depression is 23, then this angle down here, if like the nut was an object that could look up, its angle of elevation would be the exact same as the squirrel's angle of depression. Those angles are the same. What a lot of people want to do is put it in this place right here. This is never a thing. That's not a thing. Don't ever put an angle there. That's not a thing. It always goes at the bottom. So whether I say angle of elevation or angle of depression, we can put it in this bottom corner right here. Does that make sense? Everyone okay with angle of depression? We had to review it last class, so I wanted to make sure we were good. Okay, so I put my angle of depression down there, and then I wanted to find out how far the nut was from the base of the tree. So that's that horizontal distance on the ground. If I took a tape measure to where that nut's sitting to where the base of the tree is, that's how long it would be. So I want to draw my triangle, and I want to label my sides, opposite, adjacent, hypotenuse, and I'm using opposite and adjacent, which means I'm using tan. If you forget, I would write SOHCAHTOA at the top of my page just so I wouldn't forget. TOA, tangent, opposite, adjacent. So I've got tangent of my angle equals my opposite over my adjacent. Opposite over my adjacent. Everyone okay with the formula I wrote? Or the equation I wrote, excuse me? Then we solved it like we were solving the other problems earlier that day by multiplying by the variable on both sides. So I multiplied by x on both sides. I divided by tangent. And then when I put it in my calculator, I did just 52 divided by tangent of 23. Any questions so far? You kind of remember doing that? Okay, let's do as many of the rest of them as we can before we break for lunch. So again, I would suggest drawing a picture on all of them. It can be as, detailed or as least detailed as you want. This next one, we're actually finding the angle, which we haven't done before, so that'll be something new. A seagull at the top of a lighthouse spots a fish in the water below. So I'm looking at this triangle. My seagull is up here, and my fish is down here in the water. This lighthouse is this vertical distance right here, and it tells me that the goal is sitting 87 feet above sea level. So the whole distance of that like lighthouse that I'm on is 87 feet. It also says that the seagull, he is 230 feet away from the fish. Which distance is that? Is that the horizontal distance or is it the diagonal distance? Diagonal, very good. So I'm going from the seagull to the fish. That's a straight line. This is 230 feet right there. I want to find the angle of depression. We just talked about how the angle of depression and angle of elevation are the same. So you can think of it as this angle up here, or I'd rather it be in my triangle. Those are congruent. You can put them in both places. In order to figure out my trig function, I need to label my sides. So what's my opposite side? Which side is the opposite side? 87. What's my adjacent side? The unknown one. And then what's my hypotenuse? 230. Very good. I do not know my angle, so I have to use the two sides that I do know. I have to use 87 and 230. So which trig function am I using? Sine. Very good. So I'm going to write sine of theta equals opposite over hypotenuse, 87 over 230. Now, does anyone remember how to solve for theta here? So this is something we haven't talked about yet, and we're only going to touch briefly on today. I'm going to bring my calculator next to me. Remember when I was telling you how like cosecant and secant, there's no button in the calculator? Hi, Katie, go to class. And I have to do, hi, Iz, go to class. Go to class. Second lunch in like 10 minutes. Come see me in 10 minutes. Thank you. If I'm doing like cosecant, that's like 1 over sine. Did someone in this class ask about like sine to the -1? If I had done like second sine, has anyone talked about that yet? I think someone asked, I couldn't remember which class it was. We're using that right now. So when I don't have the angle and I want to find the angle, we call this the inverse of sine. Technically, the math I'm doing is to get rid of sine, I have to do the inverse of sine. You know, the inverse of addition is subtraction. The inverse of multiplication is, the inverse of sine is this sine to the -1. So technically we're multiplying that on both sides. So I'm left with theta by itself. And I'm going to do inverse sine of 87 over 230 in my calculator. We're going to explore inverse sine a little bit more later, but right now that's all we've got. If you are all done, you can just leave that right there. And I emailed your teacher, so she should know that you're coming back. Thank you. So we're going to press second sine, and we're going to do 87 divided by 230. And I got 22.2. Did anybody get an answer that was like 0.378 something? What'd you get? 0.3. Perfect. What happened here was you were in radians. So I'm in degrees. If you go to your mode and check, I'm in degrees and you are in radians. So I want to make sure that we're in the same unit. If you are able to tell me which one you did, then that's fine with me, but I need you to like be knowledgeable about it. I did not ask for either one, so technically both are correct, but you need to know which measure you gave me. Does that make sense? Okay, I'm going to do one more and then we're going to go to lunch, okay? So my answer was, in this time it was radians because I was doing, radians or degrees because I was finding the angle. Normally we're going to find a side length. And that's what we're going to find on this next one. We're going to find a side length. So this problem says, how far is an airplane from the airport if he is currently 5,000 feet above ground and the pilot's angle of depression to the airport is 17 degrees? So let's draw a picture. Oh, that's a terrible triangle. Slightly better. Okay, my airplane is in the air. No argument with that, right? There's my plane. If I could draw better, I'd draw one, but I suck at drawing. My airport is on the ground over here. So think about the airport's on the ground, my airplane's up in the air, and then the distance straight down is how far the plane is from the ground. We measure distance straight. We don't ever measure it at a diagonal. That's like hard to do, but I can go straight up and down. He is 5,000 feet above ground. So that's the distance, that vertical distance right there. it says, how far is the airplane from the airport? What distance tells me the distance from the airplane to the airport? Is it the hypotenuse or is it the horizontal distance? The hypotenuse. Good. A lot of us don't want to think it's that. We want to think it's that horizontal distance. If I say from the plane to the airport, a direct line is the easiest way to get from one point to another. It tells me the angle of depression is 17. So you can think of 17 being up here, or you can go directly and put it down in the angle that we keep talking about, space. Before I decide which trig function I want to use, let's label our picture. Oop, that's not what I want. If this is my angle, my opposite's over here, my adjacent, my hypotenuse. So which trig function do I want to use? Fine. So even though H and A are both blank, we want to find H, and you can even put an X there if you want to remember that that's the side you want to find. So we're going to find a sine. We're going to do sine in order to find X. So I'm going to do sine of 17 equals 5,000 over X. This is just like the one we talked about, the squirrel one, before we started today. And so we've done this math before, multiply by X on both sides, divide by sine 17. Now, it is super important to make sure that you're in degrees right now when you put it in your calculator, because if I'm in radians and I put sine 17, it's going to assume that I'm doing 17 radians, and that's not true. I'm doing 17 in degrees. So I'm going to stay in degrees. If you ever want to get out of your menu, just press second mode. It quits you out. And I'm going to do 5,000 divided by sine of 17. Enter. And I get this giant 17,101.5 feet. Yep. Oh. All right, questions, thoughts, comments? Okay, I'm going to stop my recording because we don't need to see this.